Hi, Algebra 2 Trig Advanced students. This is a review for quiz number 2 for chapter 3. This is going to cover briefly remainder theorem, synthetic division, polynomials, long division, and the fundamental theorem of algebra. So let's get started. The first question says find the remainder when you have this equation, and that is divided by x minus 2. So what you're looking at for a problem like this is basically you can use long division or you can use synthetic division depending on what you prefer. Okay, I'm going to use synthetic division, but regardless if I use synthetic division or long division, either way, I'm going to have to put in placeholders because your exponents do have to be in decreasing order. So 4, 3 should be a 2 and then 1, etc. So rewriting this, I would have x to the fourth plus 3x to the third plus I don't have an x squared. Minus 2x, and then plus no value. So when using synthetic division, you have this little box here. That number here is if I set that equal to 0, I would get x equals 2. That's going to go in here. The numbers, which are my coefficients, go in the front. So that's just going to be 1, I have 3, I have 0, negative 2, and 0. And so I'm just going to, the rule for synthetic division is adding down and multiplying across. So we're going to add down. 1 plus no value is 1. Now I'm going to multiply across. 1 times 2 is 2. 3 plus 2 is 5. Okay, add down. Multiply across. 5 times 2 is 10. Add down, 10. Multiply across, I get 20. Add down, that's 18. 18 times 2 is 36. Add down, I get 36. So basically, my remainder is 36. Okay, that's just the short answer of that. However, if you are required to write this in a specific form, like, okay, so you would say, well, if this started off as an x to the fourth power, this term is 1 less because I'm dividing by x. So what happens is this will be 1x to the third power. That's a positive 5, so it'll be plus 5x to the second power, positive 10, so plus 10x, positive 18, so plus 18, and therefore this value here is plus 36 over my divisor, which is x minus 2. So the next question says, what are the possible combinations of zeros? So for when you're looking for zeros, what we're looking for is how many real and imaginary or complex numbers can I have out of each of these equations? And what you're specifically looking for is the highest power, okay, and then going from there. So for example, for this one right here, something to remember is that imaginary roots only come in pairs. So that means they only are multiples of 2. So for this right here, I could have 2 real roots. I could have 2 real roots with 2 imaginary. And some people use the word imaginary and some people use the word complex. Whichever word is, complex I like is a better word technically. 2 real, 2 complex numbers or 2 complex roots. I could have actually 4 real roots. I could have 4 complex roots. And that, I think that's it. You can't have 3 and 1. Because, I mean, I can have 3 real, but I can't have 1 imaginary. So imaginary numbers only come in 2. So I either have 4, or I have 2, or I have none. Okay, and that's it. For this problem here, for the x squared, I could have 2 complex, or I could have 2 real. You can't have 1 and 1 because, remember, complex come in pairs. For x to the fifth power, I could actually have 5 real zeros. Okay, or I could have 4 complex zeros and 1 real zero. Okay, I could have 2 complex zeros, and that would give me 3, and that would give me 3 real zeros. Okay, 1 complex, nope. I can either have 2, 4, or that's it. Okay. For this question, it says list all of the rational roots. Okay, when they're saying rational roots, what they're actually asking me to know is what are all the values that I could try to plug in. So like if I was using synthetic division, what are all the values that I could try to go in here? What would those values be? And so using the rational roots theorem, what it does is it does this. It says take this number here and take all the factors of that, and we'll call that, let's say, P. And you would then take all the factors of this number here, and let's call that Q. And so you're going to take P and put P of X and put that over Q of X. And that's technically all the factors. That's what you're doing. You're finding those factors, okay? So what we're doing is all the factors of 4 are 1 and negative 1, 2 and negative 2, and 4 and negative 4. The factors of 3 would be 1 and negative 1, and 3 and negative 3, so plus or minus 3. And so these are all my factors. And so realistically, what I would do then is I would take these factors and I have to divide. So I'm going to go 1 over 1, and I'm going to go 1 over 3. Then I'm going to go 2 over 1, 2 over 3. 4 over 1, 4 over 3. That's what you do. So you're going to go, okay, factors would be 1 divided by 1, so that's plus or minus 1. 1 divided by 3 is going to be plus or minus 1/3. Then now I'm on to the 2's, 2 over 1. So it'll be plus or minus 2 over 1. And then I've got 2 over 3, plus or minus 2 over 3. And then I've got 4 over 1, so I've got plus or minus 4 over 1. And also plus or minus 4 over 3. So here are all the factors that I could actually try to factor in if I was like doing synthetic division that would go into that. That's what I would try to come up with a 0. So for example, for this problem here, same kind of thing. I'm going to take this value here. It's going to be the plus or minus of those factors, okay, over plus or minus of those factors. So we're going to go plus or minus 1, and that's the only factor of 1. So that's over the factors of 4. So these are factors, okay? Factors of 1, and these are factors of 4, right? These right here were factors of 4. These are factors of 3. So plus or minus 1, and this is going to be plus or minus 1, plus or minus 2, plus or minus 4. So realistically, all the choices I have are 1 over 1, so plus or minus 1. I've got 1/2, so plus or minus 1 over 2, and 1/4, so plus or minus 1/4. So these are all the factors for those. Okay, and you do have to write them. You can't leave your answer in this form. I mean, you probably would get partial credit, but you're not going to get full credit unless you do it this way. Okay, the next question says, determine if x minus 2 is a factor of that. There's actually 2 ways that I could do this. Way number one would be to use synthetic division. So plug in 2, right? 1, 4, 3, 2, 1, 0. So that's all descending order. So I'd go 1, negative 2, 1, negative 1, 6. And then I would do synthetic division. Option 2 would be to plug the value in here. And that would be equal to 2 to the 4th power minus 2 times 2 to the 3rd power plus 2 squared minus 2, add 6. Okay? So let's add down. Add down, I get 1. Multiply across, I get 2. Add down, I get 0. Multiply across, I get, that's 0. 0 times 2 is still 0. 1 plus 0 is 1. Multiply across, I get 2. Add down, I get 1. 1 times 2 is 2. 6 plus 2 is 8. Bummer. So I got 8. If I didn't get a 0, if you didn't get a 0, then what number did I plug in? X minus 2 is not a factor of this equation of f of x, okay? Your optimal goal is to find a 0 there at the very end. I mean, it looks like a 0, but it's actually an 8. Okay, so let's just double check our work. So let's plug in 2. We got 2 to the 4th. That's 2 times 2 is 4, times 2 is 8, times 2 is 16. Minus 2 to the 3rd power is 8. 8 times 2 is 16. Plus 4 minus 2, add 6. So these cancel, right? 4 minus 2 is 2. 2 plus 6 is 8. So plugging in f of 2, I do get 8. Now, I mean, technically it's not a 0, but I do have a point on my graph. If I wanted to graph it, the point would be 2, 8. But the question says, determine if this is a factor. It's not a factor if this doesn't become 0. This value has to be 0 for it to be a factor. Otherwise, it's not a factor. The next question says, write the equation of a third degree polynomial whose zeros are 2 and root 5. But it said it's a third degree. So that means that it's a cubic, right? X to the third power. So we're going to say f of x is equal to the first root, which is 2. So that'll be x minus 2. Then I have got x minus the square root of 5. But remember, roots and imaginary numbers come in pairs, right? We got this, right? Remember that slide that's got the hands holding pairs? Okay, so that means that even though it's a minus here, this is going to be an x plus. All right. Do you see this right here? Write the equation. If I ask you just to write it out as with, like this, that's all you would do. But if I say to put it in standard form, this is not standard form. So let's just practice multiplying for a second. Let's do these first because that's the difference of two squares. The middle term is going to cancel out. So let's see what happens. X times x is going to give me x squared plus root 5x minus root 5x. Well, those are gone. And then minus square root of 5 times square root of 5 is square root of 25, which is what? 5. So this right here becomes x squared minus 5. And so that's going to be multiplied by x minus 2. Excuse me. And so let's get that working. Multiply this times this. So we've got x to the third power minus 5x minus 2x squared minus negative. So that's plus 10. So that means that f of x is going to equal x to the third power minus 2x squared minus 5x add 10. And so the equation in standard form is this. But you do need to know a couple of things, right? If it's a third degree, you do need 3 roots. And, big hint to yourself is that if you have an imaginary number, like if it was x minus I, you have to have x plus I. Keep also in mind that when you're subtracting and adding like the same values here, the middle term will always cancel out. For example, if I had had imaginary numbers like x minus I and x plus I, right, the middle term will cancel. So you should be, cognizant of that too. Using long division, divide. Okay, so let's see, long division. So let's make sure 3, 2. I don't have an x. Okay. So let's do this. All right. So we've got 6x cubed minus 2x squared plus no x minus 1. And then on the other side, I've got 3x minus 1. So here we go. 3x times what is 6x cubed? So that's going to be a 2x squared. 2x squared times 3x is going to be 6x to the third power. 2x squared times negative 1 is going to be minus 2x squared. So we're going to subtract this quantity. This cancels. Negative 2 minus negative is positive. So that's no value. So that's going to be plus 0x squared plus no x because I bring that down. So we have 3x times what? Nothing. No value. Okay. So 0x times 3x is going to be no x squared. And 0x times negative 1 is still no x. Okay, and then we're going to subtract. We get 0. Bring down the next number, and we are done. That's my remainder. So technically for this problem, we have 2x squared plus no x, and my remainder is negative 1 over 3x minus 1. So that's kind of unique. Gosh, I would try to do another problem just for fun. Let's do another problem just to make one up. Okay, so using long division again, let's pick a different number. Let's do 3x to the third minus 2x squared plus 4x plus 1. Okay, 3, 2, 1, 0. And let's just try x plus 1. Let's divide this into this just for practice because the other one was kind of weird. X times what is 3x cubed? So that would be 3x squared. As soon as you get your number up on top, that number gets multiplied by everything in the divisor. So that'll be 3x squared times x, which is 3x to the third power. 3x squared times 1 is going to be 3x squared. We're going to subtract the quantity. This first term cancels. Negative 2 minus 3 would be negative 5x squared. bring down the next term, so 4x. Okay, I'm going to erase this part. And so now I start over again, and I go x times what is negative 5x squared. So that would be negative 5x. Negative 5x times x is negative 5x squared. Negative 5x times 1 is negative 5x. I'm going to subtract the quantity. These cancel. This minus negatives plus. 4 minus negative 5 is plus, so that'll be 9x. Bring down the next term, which is plus 1. X times what is 9x? That would be plus 9. 9 times x is 9x. Not sure if you can see that. 9 times 1 is 9. And you subtract this quantity, 9 minus 9, that cancels. 1 minus 9 is negative 8. So my remainder is negative 8 over my divisor, which is x plus 1. Okay? All right. And that's how you do that problem. So that's all I have for you. That's all that's on the quiz. It's pretty quick, pretty short. Good luck on your quiz, and yeah, go watch Han Solo, because that's amazing Star Wars. Okay, I'll see you tomorrow. Bye.